Alrighty, so hello everyone. Today we will be going over our coding bat lesson once again. So as you can tell from the title, we aren't going to be going over like any new topics today. We are actually going to look at how to be able to solve the problems that we've gone over already in a faster method, a more efficient method, and one that is easy for you to apply yourself. Because I received some feedback that many people were struggling to keep up, and even though the material made sense to them, it wasn't actually that easy when it came to programming themselves. So I'm going to go ahead and I'm going to explain the logic behind how you should try and program everything, whether it be a coding problem, a full-on program. It can be almost anything, but these are some major steps that you should probably take. First up is something called a pseudocode. So a pseudocode is it's a programming term which is used in programming and algorithm-based fields, and so again, it's something used to kind of write out the algorithm. Now you may be asking, well, what exactly is an algorithm? Well, we can Google that as well. Whoops, algorithm. So an algorithm is essentially a process or set of rules to be followed in calculations or other problem-solving operations. So again, this is very technical. We might not necessarily entirely understand what is going on. Essentially, we can just go ahead and go into images. We can see that in the algorithms, we can see there's this entire chart here. Now this chart can be confusing when we look at it, because there's obviously a lot of arrows going everywhere, there's a lot of different boxes, but in the end, we want to go from input A to end. And the steps that we take there, it's important for us to clearly be able to understand the logic behind it before we go ahead and actually program it. Now, when we go ahead and we try and program something, there's two major kind of ideas or concepts that must be fully understood. One is going to be the algorithm, the actual kind of logic behind whatever code that we're writing. So essentially being able to go out and write the pseudocode. So this is an example of what pseudocode would look like. It looks exactly like a program, but instead of actual programming, we are just going to be using like words, so it's easier for us to kind of understand it. And the second part is being familiar with all the tools that we can use. Now, what do I mean by tools? Well, in programming, our tools are the different kind of functions that we can call, the different statements that we can write. This can be if statements, this can be for loops. Basically anything that we can program is going to be a tool that we can use. Now when we learn new things, especially when it's something that's not really familiar to stuff that we've done before, it can often be a hard time to fully kind of grasp a concept. And I understand that, and so that's why we're going to go back today and we're going to kind of check up and make sure that you guys fully understand what exactly is going on here. Now that brings me to my second point. My second point is in coding bats. What exactly is the goal here? What do we want to accomplish? Well, if we can look at it, we can see that there's this Java section, there's this Python section, and both of these sections, they have multiple different topics. We go through all these kind of basic topics going through strings, array, logic, and we get into harder ones with maps, functions, recursion, right? But ultimately, these programs, they're not necessarily supposed to be full entire programs, but situations in which you will use each one of the concepts that we learn. What I mean by this is each one of the concepts here, say take string, there's many different actions that we can perform given a string. And the purpose of all of these programs here are to make sure that we understand all of the different actions. So it's perfectly fine for us to understand only half of it but not the other half, because oftentimes there's going to be more than one part to this kind of string topic. And in order for us to completely be able to perform all of these programs, we need to make sure that we understand both the actual code and the pseudocode. And oftentimes, many people just go ahead and completely ignore the pseudocode. And that is not a very good idea, because writing this down, having your idea out here like this, makes programming it so much easier. So, I'll let you look at this pseudocode for a second. Now, obviously, you're not going to understand exactly what's going on here, but just kind of get an idea, and I'll explain to you how this pseudocode kind of works and how we can use it to our advantage. Alright, now that you guys have kind of had a good look at this, um, oh, Raphael Green, sorry if I pronounced that wrong. Yeah, we were just kind of examining the code over here, the pseudocode. So now I'm going to kind of explain exactly why you would want to do this. Now, we look at this, and we can see, alright, well, this already looks like a format of whatever code you would want to write, right? It's just kind of all your code, except instead of using like 4k is equal 1 in this list of k, blah blah blah, we're just writing it in our English terms. But that's what's so special about pseudocode, because many times we're not entirely familiar with how we can kind of go ahead and write out our code. But when we think about it, just in terms of how we would say out loud how we would solve this problem, it's oftentimes a lot easier for us to do that, because we understand it a lot better. And as does everyone, whenever you understand something better, you'll be more comfortable to do it, and you'll do it more often. So that is kind of the basis behind pseudocode. And so I'm going to do a couple of examples of it in these problems over here. So I'm going to try to cover as many topics as I can in this lesson today. So first one we're going to do is we're going to hop into string 1. And I'm not going to do the questions that we've already done so far. So we can go ahead and we can just look at non-start over here. So I'll give you guys about a minute to look at this question, and once you kind of look over the instructions, look over these test cases, I'm going to go ahead and teach you guys how to properly kind of write your pseudocode. Alright, so when we go ahead and we first look at this, so we're given define non-start, and we are given the parameters a and b. And again, if you don't entirely know what a function is just a short program that you can call multiple times. So essentially, when we go ahead and if we're to run this, we have to return something here, don't we? So if we were to run this, and we can kind of see, we got all the test cases wrong, obviously, but we can see that it runs the program multiple times with different words inside each one of these. So in this case, A is equal to hello, B is equal to there. In this case, Java is equal to A, code is equal to B. And what's running behind the scenes is essentially, it's just calling non-start, and it's just going to type hello there. Just like that. And when they go ahead and run this, it's just going to put this over here, and if they want to print the result, then all they have to do is just write the print statement. Alright, so that's all that's happening behind the scenes. There's nothing too complicated, but let's get back to the program. So, given two strings, return their concatenation, except omit the first character of each. The strings will be at least length 1. Now, when we think about this, and we go ahead and we try and write this, it might be a little confusing at first, obviously, because, well, how would we kind of put them together and shrink the strings by length 1 for each of them? So, you write return A without character at index 0, or return A without the first character. Alright, now this is the first part, and we have to add the second part. Plus, or plus, it doesn't really matter what you use, B without the first character. And what this does is we can easily understand this. Return A without the first character and B without the first character. So if we go ahead and we take the cases hello and there, we can easily tell, alright, well, A without the first character is just LO, and there without the first character is just here. And we can see that the run case, the case that they want to be returned, is just LO here. And these two match each other, so it's not really that, it's easy to kind of come up with our solution. And this is important in making sure that you do this first, because many times you won't even understand the question properly. Because oftentimes they'll use very technical terms. You won't entirely understand what exactly is happening, because oftentimes we can easily get confused. And by writing this out, it's easy for us to run through the program without actually having to write it. Now, when we go ahead and write this, alright, so we'll write a new line here. So we have our basics. So we want some form of A plus B, right? But because we don't want the first character, we have to think back, well, how do we return only a part of a string? And sometimes you'll know whatever the question's asking you, sometimes you won't. And there's a couple ways you can go about this. Now, the best and most efficient and probably most accurate way is using Google. You just search up, how do I return a part of a string? And gotta make sure you put Python in there. And you'll see you get all of these results. Now, typically you're gonna try and stick with the first probably 5 to 8 sites, and most of the times, as long as it's a pretty general question, it will be answered to your satisfaction within these 5 to 8 kind of websites. So we're just gonna go ahead, go into the first one, freecodecamp.org. This is a pretty good website. I actually recommend that if you wanted to, you can go ahead and search through this website yourself. They have some pretty good practice problems. So we can see that this is called a substring, and this is often called slicing. And this one makes sense because, well, we're slicing the string into multiple parts. Now, in our case, we're just going to be throwing away one of the parts. Obviously, you can do more than just throwing it away, but in our case, we got to look at this. So we have string start, end, and step. So what do all of these words mean? So we have start. So start would indicate the beginning index. And it's important because this beginning index is included. It's inclusive within this substring. So if we were to put 0 there, it would include the index of 0. However, in end, which would be, well, the end of the substring, this would not be inclusive. So essentially, we would stop right before the end index. Now, why they did this, I'm not entirely sure, but that's kind of just how it works. And finally, we have step. And step is going to be kind of what it means, but essentially it will go this many indexes at a time. So what does this mean? If start is index 0, end is index 10, and step is 2, it goes 0, 2, 4, 6, 8. If start is 0, end is 10, step is 3, we go 0, 3, 6, 9. And so on and so forth. There are obviously many different combinations you can put in this. And since this is step can be kind of excluded, there's actually many ways we can write this. Now, the most traditional way is going to be just writing string start to end. And typically, we don't need to include a step because we usually don't want to skip many characters. And this is because when we skip over these characters, there's probably a very specific reason. And why you would want to do that, obviously that pertains to your individual case. I cannot entirely answer that, as each one of the programs that we write will be unique in some way or another. So we have the traditional case. We have string semicolon end. So end is the only parameter. However, there's actually a hidden parameter in start. And when you include, or rather, when you don't include either end or start, it will substitute it out for a special value. When you don't put in start, it automatically assumes 0. And when you don't put in end, it will automatically assume the end of a string. And when we go ahead and write this, there's many different ways we can write this. Because when we go about this, these indexes can actually be negative. Now, do I suggest we go ahead and we write negative indexes? No, I do not. And the reason for this is because intuitively, when we think of a substring, when we think of anything, we like to go from left to right. Whether it's reading a textbook, typing out a line, pretty much anything that we do that's related to going in some sort of order, we like to go from left to right. And this is because throughout the years we're obviously trained to do this. Everything that we do is put in this kind of order. And it's important to not try and mess around with this order, obviously, because reading from right to left is obviously harder than reading from left to right. And just to show you guys that it is actually easier, if we were to look at this, say free code camp, and we see free code camp here. Now, it's pretty easy, even though there's no capitalizations. We can see, alright, well, this is obviously just free code camp. We can easily simplify this out, and we can split up the 3 words. Now, if we were to write this into a reverse order, it's much harder for us to read this. Even if we know that we're reading from right to left, we'd have to decipher, alright, well, this is free, that is code, and that is camp. And it'll look very weird in our perspective. So I strongly suggest, unless there's no way around it, that you should go ahead and just use positive indexes. Now, when we come over to this example, we can see, alright, well, when we go ahead and use the positive index here, since we just want to not include the first index, or the index of 0. Remember, strings start from index 0. Actually, everything starts from index 0. We want to go ahead and write 1 to len of a. But since this is len of a, and we know that when we don't include end, rather, it will automatically assume len of a. So we can just go ahead and write 1 semicolon. We can do that again with b. And we can see the pseudocode over here matches the code that we actually wrote. So I want you guys to kind of think about everything that we just kind of covered right now. And it may seem kind of extra for just this singular line of code right here, but it's important to understand that there are many different steps that you have to take to properly do a program. And however short, however long a program may be, these steps are always applicable. And typically, when teaching, it's a lot easier to understand from both the student's perspective and from the teacher's perspective to kind of cover every single aspect on shorter programs. And as you get into longer and longer programs, you're going to get more and more familiar with this. And as you get more and more familiar with this, you're going to start being more comfortable using, being able to use Google at your hands. Because, well, frankly, Google has practically everything. Every single command you want. It has even entire algorithms, like printing out like a Fibonacci function. It will have the entire function written out for you, not just how to write that type of function. Essentially, Google is a very powerful tool. But with that, it is important in understanding that however powerful Google may be, you cannot entirely rely on it. I'll cover that after you guys kind of think about what we just went over. So I'll give you guys a minute for that. Alright, so hopefully you guys were able to kind of go over it. Obviously, you probably weren't able to catch everything, but as long as you got a majority of it and you understand what's really going on here, you can see that this pattern can be applied in longer programs. And some classic programs that you might want to kind of consider looking at are, well, at least they include being able to write the Fibonacci sequence to the n number of numbers. What I mean by this is If we say n is equal to 4, then it'll print 0, 1, 1, 2. So this is a classic one. And obviously there's going to be a lot more. You can find them pretty much everywhere, right? But for now, I would suggest if you struggle with any of the basics, it is always safe to fall back on to CodingBat. Now, back to when I was talking about how Google can be both a tool and something that can destroy your programming base, your programming knowledge. Well, what I mean by this is because Google has literally everything, you basically need to know very little. And this can be bad, and that sometimes you won't have access to Google. And realistically speaking, obviously, if we're talking about like a program that you have to write, say for your own project, you'll always have access to Google. And there's obviously going to be some unpractical situations like school tests where you're trying to learn your material and kind of, I guess, cram it all in because you know you won't have access to any outside information on that test. Now, those tests aren't exactly realistic as you almost always have access to it. However, because programming is such a new concept, it's not something that's been around since like 5000 BC, right? I mean, even like things like math, you could see the basic formations of it. Programming was not something that was invented until after the first computer was invented. And the computer was not invented that long ago. I'm not sure the exact year, but I think after 1800 is a good estimate. So just 200 years. That is less than 4 whole generations. Just think about that. Programming still has a long way to go. And again, as a result, as the programs get more complicated, you're going to have less and less people knowing exactly how to do things. And in that small population that knows how to do it, there's only going to be a certain number of people who's going to actually go out and attempt to teach it. And that is why it's important for you to truly understand these concepts. Because programming is something where understanding the basics is essential. So essential that if you do not understand the basics, it is physically impossible to move forward. And many times, not understanding the basics can lead to even just a small error that won't let your program run. So, while this class at first may seem almost amateur, I guess, doesn't go too deep, it's truly important that for every single one of the concepts in here, you're not only able to understand what we are teaching, what we are saying, but be able to apply it in such a fashion that you almost don't second guess yourself. Now, oftentimes, it's human nature when we go ahead and we try any program that we go ahead, well, is there a better way to do this? Is this the correct way? Because, when we go ahead and we write a program, nobody likes seeing like a red X over one of the test cases. It's always much more satisfying when you have all of the checks after you go ahead and you run a program, right? And again, so this week we were only able to go through string 1, and that's perfectly fine. Obviously, we were only able to go over one question, but that one question hopefully was able to kind of teach you how to go forward in the rest of the programs that we go over. Now, next week, when we go over the questions, we're still going to be going on review. We're not going to go forward and do harder questions because I understand these concepts are getting a little tougher and the use cases are getting a little more complicated. But remember that the main things that have to be done in order to successfully write a program are A, make sure you write a pseudocode, B, make sure you understand the basics that you need to fully write a program, and C, feel comfortable doing it. And again, if you have any questions, make sure you Google it, because Google is going to be your best resource, probably not even in just programming, in probably most of your classes. So if anyone has any questions, feel free to share them right now. I will stick around for a couple of minutes and we'll try to answer any questions that any of you may have. Thank you, Aaron, and bye. Alrighty, it doesn't look like anyone has any questions. So, thank you everyone for watching, and we will see you guys on next Tuesday. And I guess see ya.